Hello everyone. Welcome to our webinar. I see that some people are still trying to join us. That is why we'll probably wait for a few minutes, I guess. My name is Julia and I'll be your host today. And while people are joining us, I would like to tell a little bit more of what to expect from our webinar. And first of all, I would like to tell you that this webinar is Grania's initiative, and it was done in collaboration with our British partner, Compass North Aviation. And I'm very glad to welcome everyone today. And having two companies involved in this webinar means that there will be two speakers today. Before I introduce the speakers, I also want to shed the light on our agenda today. So can I please see the agenda? Oh, yeah, here it is. So first of all, we'll speak about the basics, since the topic of the webinar is aircraft engines and their management. So we'll first talk about types of engines popular in commercial aviation. We'll talk about technical side, since it's important. Probably it may seem obvious to some of you, but anyway, it's important to remember, to refresh the memory in order to proceed with much more complicated things. And then we will dive deeper into aircraft management and in particular aircraft engines. We'll talk about airworthiness guidelines to maintain an aircraft engine. And the third actually topic which we'll discuss will be COVID-19 effects. This is, again, I guess, the most burning issue nowadays, and I believe it will be interesting for everyone to listen to our speaker in this regard. And now let me introduce our first speaker, who will be Daniel Grania. I guess you know him since he's Grania's founder and chief technical officer. He's got 9 years of hands-on experience in the field of CAMO, part 145, in engineering, planning, and project management. So he contributed and managed numerous projects of different kinds on behalf of various organizations from all over the world. He used to work projects in Denmark, in the USA, Colombia, Brazil, France, and many other countries. So his experience is really versatile, and he has things to share with you, which worth listening to, I believe. And the second speaker today is Adam Harris. He's a director of Compass North Aviation, our partner. And he's got more than 20 years of experience in aviation. He started as a licensed engineer and went his way through such positions as head of engineering department for Eurojet, and he also performed as a continuous airworthiness manager for Gulfstream Aerospace. An impressive experience, isn't it? So I hope you'll enjoy this webinar, and I won't drag the time, but pass the word to Daniel. So, Daniel, are you with us? Hello?
Yeah, 1 second. I'm trying to, yeah. Can you see me?
Yeah, perfect.
Oh, okay. First of all, thank you very much to everyone who decided to assist to this webinar. The purpose of this webinar is to show us a little bit more about management, basics, and I will go through the basics, and at the end, I'll go through the COVID-19 situation. Basics, what's an aircraft engine? Well, in basic words, it's a machine designed to convert one form of energy to mechanical energy, which is going to propulse an aircraft. Through its accessories, it can generate electricity, and it has a vital function in the pneumatic systems between other systems. Today, we're going to talk about 3 types of engines very quickly, but we're going to concentrate on turbofan engines. So let's go first to the piston engines. The piston engines, they are commonly referred as a reciprocating engine, or as an internal combustion engine that uses one or more reciprocant pistons to convert pressure into rotational motion. Examples of aircraft that use this type of engine are Beechcraft, King Air 360, as you can see in the slide, Cessna, Skyline, Bonanza. Turboprop engines, they are a turbine that are connected to a gearbox and a propeller. Most commonly used in ATR, of course, only used on ATR, Dornier -8. And now we're going to go to a small video about how a turbofan engine works. Let's go with it.
A turbofan engine. This is how it looks like in the inside. And it's composed of the fan, followed by the core, which is split in 3 sections: compressor, combustion chamber or combustor, and turbine. Compressor. Compressed air makes for a much more powerful combustion reaction. Compression happens in stages that force incoming air into an increasingly narrow chamber. Rotor blades swirl the air as they force it through the compressor and create a much bigger pressure. Combustor. It is the place where the compressed air meets with the fuel and the resulting mixture is ignited, releasing a jet of super high powered gas. Turbine. Located at the rear, it is powered by the exhaust gases exiting the combustor. Much of the power of the turbine is used to turn the fan, while a smaller percentage powers the compressor stages. Fan. A fraction of the air that passes through the fan goes to the engine core, while the other percentage is used for cooling, releasing high quantities of air at slower cruising speeds, etc.